Sequence and series, type 2, the nth term. So our nth term we established in the last video, and we can also see it here on page 22 in our maths tables, where t of n is equal to a plus n minus 1 times d. And this is for arithmetic sequences. Where an arithmetic sequence is one that has a common difference or a constant added to every single term. And obviously that constant can be a positive whole number, a negative whole number, it could be an irrational number, it could be a fraction. But it is constant, so the difference between every term is constant, it's the same. So what we're going to look at today is basically how can we find the general term, how can we find a specific term, and how can we find what position the term is in the sequence. So if we look at the example here, we're given a list of numbers, 5, 8 and 11. And the first thing we're asked to do is write down the first term. So A is our first term, which we can see is 5. And then we have to write down the common difference. So if we write T1, T2 and T3 over each of my terms, then to find D, my common difference, all I have to do is get the difference between any two consecutive terms. So therefore D in this case is going to be 8 minus 5, which is 3. So now we have our first term and we have our common difference, and we're told it's arithmetic, so we'd always underline that in our question. Then it says write down the nth term. So the fact that I'm told it's arithmetic means I go to page 22 in my maths tables, I look at the arithmetic section, which is the middle part of that page, and I write down my formula for the general term, or the nth term. And we say if A is 5 and D is 3, then the nth term is represented by 3n plus 2. So now I have the general term for this arithmetic sequence. I can find whatever term I want in the sequence by simply replacing n with whatever position I'm looking for. Now you could of course just keep on adding 3 and adding 3 and adding 3 and adding 3, but obviously if we were looking for the 100th term or the 200th term, it would be quite tedious to keep adding on 3 to get there. So that's why this general term is going to come in very, very handy. So part 3 then says hence or otherwise find the 17th term. So T17. So if we're looking for T17, that implies that we're letting n equal 17, which means then that I can put in 17 wherever there's an n. So we have 3 times 17 plus 2, which then gives us 53. So in other words, the 17th term is 53. Okay, so for part 4 then says, well, which term of the sequence is 122? So what that means is Tn is 122, and we want to know what position does 122 hold in our sequence. So of course, as I said, the long way would be to literally keep on adding on 3 to our sequence and then circle 122 when we find it and then count up how many numbers is that, but that would be a very long time. So what we would say is instead of T of n, we're putting in our general term, so 3n plus 2, and we're looking for 122, so therefore 3n equals 120, and therefore n equals 40. So what that means is that 122 is the 40th term in the sequence. So you're going to do page 201, question 1, 2, 5, 6, 19 and 20.